So we look at the roots of quadratic functions. So the first question is, one, if alpha and beta are roots of the equation -2x squared plus 2x minus 7 is equal to 0. Find the quadratic equation whose roots are 2 over alpha and 2 over beta. I think this is one of the questions that came in the test. And it was also there in that one. I got it from last year's supplementary exam. Then I get something from last year's initial exam. If alpha and beta are roots to the equation (2x squared minus 3x plus 2 is equal to 0), find the equation, find the quadratic equation whose roots are 1 over alpha beta and 1 over alpha plus beta. Solution. So mostly I use questions from 1120 for those doing 1100, because it looks like 1100 is a subset of 1120. So I go for the bigger one. Though not in most cases, but I'm able to tap what is missing in the other course. Okay, so solution, question 1. Well, one thing we must know is ax squared plus bx plus c is equal to 0. This is a general quadratic equation. And we know that if the roots of this quadratic are alpha and beta, the sum of those two roots is going to be -b over a. And the product is going to be c over a. So given -2x squared plus 2x minus 7 is equal to 0. This tells us that a is -2, b is +2, c is -7. So we know that if we add alpha and beta, we will get negative b, which is 2, over -2, which is a, which is 1. If we multiply the 2, we'll get -7, which is c, over -2, which is a, giving us 7 over 2. This information is necessary. They are very important in us obtaining the equation whose roots are 2 over alpha and 2 over beta. because the new equation, okay, the new equation is going to take the form x squared x squared minus sx plus p is equal to 0. Okay, where s is the sum of 2 over alpha and 2 over beta, and p is the product of 2 over alpha and 2 over beta. So we get the sum. So let's get S. S is equal to 2 over alpha plus 2 over beta. The common denominator is alpha beta. Then alpha into alpha beta, we get beta, and then we get alpha. We factor out 2, then we'll have alpha plus beta on top, and down alpha beta. Well, but we know what alpha plus beta is. It's 1. So 2 times 1 over alpha beta is 7 over 2, which is 2 multiplied by 7 over 2, which is 2. So when I multiply, I must switch. So I didn't switch there. So when you multiply, it becomes 2 over 7. So we get 4 over 7 as S. The product, P, is 2 over alpha multiplied by 2 over beta. This is 4 over alpha beta, which is 4 over 7 over 2, which is simply 8 over 7. So this is the product and this is the sum. Therefore, the new equation is x squared minus s is 4 over 7 x plus p is 8 over 7 is equal to 0. Some questions, they would demand that where a, b, and c of that new equation is a whole number. In such cases, you multiply throughout by 7 by the highest degree in the denominator, or by the lowest common multiplier, so that we get 7x squared minus 4x plus 8 is equal to 0. So this will be the case. So we are sensing what is going to happen when we bring in question, when you go to question 2. First, we'll find alpha plus beta and alpha beta. Then we'll start looking for S and P of the new equation. So let's go there. Question 2. We have 2x squared minus 3x plus 2 is equal to 0. Then we find alpha plus beta. That will be 3 over 2. Then alpha beta, that will be 2 over 2, which is 1. Then, Matthews.
Say, how do we get alpha beta?
Alpha beta, you just divide C over A from the general quadratic equation.
Okay.
Yes. Okay. So after we have alpha plus beta and alpha beta, we now look at the new equation. It would take this form where S is given by 1 over alpha beta plus the other root is 1 over alpha plus beta. Not complicated. You already have alpha beta, so you just place 1 over 1 plus 1 over, you already have alpha plus beta, 3 over 2. So this is 1 over 1 plus 2 over 3 when you reciprocate this one. And then the common denominator here is 3. So we get 3 plus 2, which is 5 over 2. Then we get P, which is 1 over alpha beta multiplied by 1 over alpha plus beta. Well, if you want to make your life hard, you can expand here so that you have alpha squared beta plus alpha beta squared. That is just wasting your time, because even if you expand, for you to get this correct, you have to factorize. So you avoid doing that. Since you're already given 1 over alpha, I mean, we know alpha plus, I mean alpha beta. So you just substitute where there's alpha beta, you put 1. And then where there is alpha plus beta, you put 3 over 2. And now multiplying. This is 1 over 1 multiplied by 2 over 3. So we get 2 over 3. Then you say, so the new equation is x squared minus s, that is 5 over 2, x plus p 2 over 3 is equal to 0. Should they demand for whole numbers, you multiply by the lowest common multiple, where 2 and 3 can go. That is 6. Then you have 6x squared minus 2 into 6, that is 3. 3 by 5, you get 15x. Plus 3 into 6, that's 2. 2 by 2, we get 4, giving us 0. That becomes the solution. Hello.
How did 3 change to 2? When we were finding the sum, when you do 2 plus 2, 3 plus 2, it will give us 5. Then how did this denominator, how did this 3, which is in the denominator, change to 2?
Oh. 1, 2, 3. No, it's still 3. It's still 3. It's still 3. So this is 1. So it's still 3. Oh, it's everywhere now. Is it? No, the other side I was careful. So it's still 3. So you put 3 here. So meaning you just multiply by 3. So that we get a 3x squared minus 5x plus 2 is equal to 0. Okay, thank you for that. Okay, in this paper there was nothing on discriminant. In the other paper there was nothing also on discriminant. Okay, there was nothing on discriminant in the last year's exam. So that says nothing about this year's exam. I cannot. Okay, so question 3, determine the nature of the roots of the following. A, 2x squared plus 5x plus 7 is equal to 0. B, 4x squared plus 20x plus 25 is equal to 0. And then something for applications. I'll put it on question 4. Find K for which the following hold. A, 3x squared minus 4kx plus k is equal to 0 as real roots. And B, 3x squared plus kx minus 2 is equal to 0 as roots whose sum is equal to 6. And C, 5x squared minus 8x plus k is equal to 0 has roots whose product is equal to 1/5. Solutions. Oh, the first one, determine the nature of the roots of the following. For the first question, you realize that the discriminant, which is b squared minus 4ac, is the one that tells us the nature of the roots that a quadratic have. In these 4 cases, the first one, if d is equal to 0, then the quadratic will have equal roots. The second one is if D is greater than 0, then it will have distinct real roots. So the first one also, they're not just equal, they are equal real roots. Now we see something common. We have real, meaning the third case can actually combine these two. If we have greater or equal to, then we'll just leave out equal and distinct. We'll just say we're going to have real roots. The fourth case is if the discriminant is less than 0, then we have complex roots, which we call imaginary roots. So you go for case A, we just find the discriminant. B, if you look at our A, this is A, B, C. So go straight and write D, B squared, so we get 5 squared minus 4, A is 2, and C is 7. What value do we get? We get 25 minus, that is 8 times 7. I think that should be 56. 56, which is equal to 25 25 minus 56, that is negative 31. This number is less than 0. So we have imaginary roots. Hello.
These three, they usually confuse me. These are the first one, the second one, and third one. Isn't it that the third one is just the sum of the first one and the second one?
Yeah, it's a combination of the two.
So why do you put it there? Because is there any condition where you find such situation instead of first one or the second one or fourth one?
Yeah, so you hold a bit and see what happens on question 4.
Okay.
So when you go to B, we find the discriminant is equal to B squared, that is 20 squared minus 4, 25. So 20 squared, that's 400. 4 times 25, that's 100. 100 by 4, that's 400. So we get 0. So when we have 0, then we say we get equal real roots. That was question 3. That one is a bit simple. Let's go to question 4. Question 4, part 1. Find k for which the following what? That is A. 3x squared minus 4kx plus k has real roots. So 3x squared minus 4kx plus k is equal to 0. So we are talking of it having real roots.
Say
Real
on question 3.
roots. Yes.
Yes, on question 3. That is the solution for question 3.
Yes. We just
Okay.
wanted to mention the nature. Will they be real? Will they be complex? Will they be equal real or something like that? Using these conclusions.
Okay, I understand.
Okay. Now we're on 4. Find k for which the following hold. The first one is 3x squared minus 4kx plus k has real roots. Has real roots. Has real roots. Are they equal? Are they distinct? We don't know. The only thing we know is that they are real. They can be real equal or real distinct. So we use case number 3. D is greater or equal to 0, where there will be real roots. And that's the reason of talking about it. I hope you see the need now. So if we didn't have,
Not really.
if we
Not
didn't
really,
have,
sir.
You pick
Look.
up the same.
if we didn't have, if we didn't have case 3, if this wasn't there, and the question is saying find k for which this will have real roots, which case would you take between case 1 and case 2?
Oh, okay. Yeah, I've seen now.
Good. So we use d greater or equal to 0. But what is d? D is b squared minus 4ac. It must be greater or equal to 0. So b is negative 4k. And then square minus 4. A is 3. C is k. This must be greater or equal to 0. So here we get 16k squared minus 12k is greater or equal to 0. Well, if we factor out what is common, 4k is common, and we remain with 4k here minus 3 the other side is greater or equal to 0. This is a product. So for a product, you get critical, you get the critical values. This has become a pure inequality question now. So you get 4k is equal to 0, so that k is equal to 0. You also get 4k minus 3 is equal to 0, so that k is 3 over 4. And then you form a table. So you have 0 and you have 3 over 4. A number between these two that we can use. We can use n fraction like 3 over 8. We know it's less than 3 over 4, but bigger than 0. And then if we pick 10 on the right, we know 10 is bigger than 3 over 4. If we pick negative 1 on the left, that is less than 0. And then we are forming a table with these blocks. And then we'll have 4k. And then we'll have 4k minus 3. And then we'll have the whole thing, well, we can just call it P, meaning the product. If we substitute negative 1 where there's k, we'll get negative 4. We're interested in the negative. If we get negative 1 where there's k, we'll have negative 4 minus 3, which is negative 7. So we get positive. If we get 3 over 8 where there is k, we'll have 4 by 3 over 8. That will be positive. And then the other one will have 4, 3 over 8 minus 3. 4 here 1, 4 here 2. So we get 3 over 2 minus 3 over 1. This becomes 2, 3 minus 6. So we get -3/2. So we'll have a negative. The product will be negative. And then we'll have positive, positive, the product will be positive. So what does this give us? The interval that we're interested in is the one that is greater or equal to 0. So we'll go for the positive intervals. They're the ones that are bigger than 0. Anything less than 0 is negative. So we'll say the solution set here is from -infinity up to 0, including 0, union. You start again from 3/4 all the way up to +infinity. That is where you find the values of k that will satisfy the condition that we want for this quadratic equation. So any k that you pick from these intervals will satisfy that. Okay. A few minutes, we need to be a bit fast. 3x² plus kx minus 2. 3x² plus kx minus 2 is equal to 0. Has roots whose sum is equal to 6. That's direct sum. So if the roots are alpha and beta, then the sum is 6. So work with the sum. What is the equation for the sum? It is -b/a. It's supposed to be equal to 6. What is b in this case? It is negative, so it's k. So put a negative there. Over a, which is 3, is equal to 6. So -k is equal to 18, so that k is -18. So it goes straight to what the question is demanding. The question is saying the sum of the two roots is 6. And we know that the sum of the two roots is always -b/a. So just equate -b/a to 6. What about C? C, the equation 5x² minus 8x, 5x² minus 8x plus k is equal to 0, has roots whose product is equal to 1/5. Whose product we know, if I have alpha beta, I should get 1/5. But what is alpha beta? Alpha beta is given by c/a. So this should be 1/5. What is c? C is k, a is 5. This is 1/5. Cross multiply, you get 5k is equal to 5. So k is equal to 1. As simple as this. Do we have questions? It's, so, Matthews. Okay. So we,
Say, yes. You said alpha plus beta is equal to -b/a.
yes.
Which is equal to I didn't get where you said -k/3.
minus k over 5 or minus k over 3 here.
Yes.
So our b in the quadratic given, our a is 3, our b is k, and our c is -2. This is the quadratic that we're supposed to see. So we're saying a is 3, b is k, and c is -2. Well, we just want b over a. So we put, since it is negative b over a, which is the formula for the sum. So where there is b, we put k. And where there is a, we put 3. And then equate to the given sum, which is 6.
Then, so where did we, okay, I get it.
Okay.
Alpha plus beta is 6.
Yes.
All right.
Okay, so we bundle semester 1 work here. Mangala.
Sir, kindly explain a bit on how you are finding the critical values.
Well, we just equate each piece there to 0. So you equate 4k to 0. You also equate 4k minus 3 to 0. And then those values of k become the critical values. The values that do not tell you anything about this being greater or less. If you place them, they'll give you 0. Kaliza.
Didn't understand where you were finding negative, positive on that table.
Okay, so let's rejoin then, so that we can have more of them. Let's quickly rejoin. We do 2 or 3 examples of inequalities.